Hello children, welcome to AIMS India's online classes. In today's video, from physics subject, motion topic we are going to continue. So, we were discussing about projectile motion children, oblique projectile motion. If this is the ground, this is x-axis, this is y-axis. We are projecting a body with an angle other than 90 degrees. With an angle other than 90 degrees with the ground, then its path will be like a parabola. Then its path will be, its trajectory will be like a parabola. This is the projectile. This is the projectile, or this is the trajectory of the projectile. So this is an example of oblique projection. Means projecting the body from the ground with an angle other than 90 degrees is an example of oblique projection. In this oblique projection, now we are going to find out time taken to reach the maximum height or time of ascent. Means in this total journey, this is the point O is the point of projection. Point A is the maximum height reached by the body. Point B is the point of coming back to the ground. Actually here we are throwing with a velocity u in an angle theta other than 90 with the ground. X-axis, this is y-axis. We are throwing with the velocity u with an angle theta. But here, in the case of oblique projectile, with whatever velocity we have thrown the body, that will be split into two components, two independent components, one along the horizontal direction, one along the vertical direction. One along the vertical direction. The horizontal component of this velocity u is termed as u cos theta, and vertical component of velocity is termed as u sin theta. U sin theta. So we have u cos theta along x direction, u sin theta along y direction. The sum of u sin theta and u cos theta will be equal to u. Means same value of u only, but divided into two components, like u cos theta and u sin theta. So here now, what is the time taken to reach the maximum height? Means from the ground, the time taken to reach the maximum height, this is the maximum height. Suppose it is h max, maximum height. The time taken to reach the maximum height is called time of ascent, because it is going up, it is ascending up. So the time taken for ascending up is known as time of ascent. So let the time of ascent be denoted by Ta, small t, small a. At the maximum height, because throughout the journey of the projectile along the horizontal direction, there is no force is acting. So this u cos theta is constant throughout the journey of the projectile. But the vertical component of velocity, u sin theta, will always be affected by acceleration due to gravity z. Means at any point, if we take at any point, this vertical component of velocity will be affected by this acceleration due to gravity because of gravitational force. So in the beginning, while throwing, the velocity may be more. While throwing, the velocity direction is upwards, but due to gravitational force, the velocity decreases goes on decreasing, and what one point it will become 0. That point is maximum height point. From there it cannot go up. From there it starts falling down. Velocity will increase, and finally it touches the ground. With what velocity we have thrown, with the same velocity it will touch the ground. So while ascending up, vertical velocity will be decreasing continuously. At maximum height it will become 0. While descending down, this velocity will increase. Only vertical component of velocity changes we can observe, whereas horizontal component of velocity throughout the journey same. Why means there is no force acting in horizontal direction. So children, at the maximum height, vertical velocity at the maximum height, if this is horizontal velocity, vertical velocity, this is horizontal velocity, vertical velocity is 0. So Vy, vertical velocity is 0, but the oblique projectile is under the influence of Z, which is uniform. G value is uniform at all places. Acceleration due to gravity value is 9.8 meter per second square on the earth. Means the oblique projectile is under uniform acceleration. It's an example of uniformly accelerated body. So oblique projectile is an example of uniformly accelerated body. So equations of motion we can apply. According to equations of motion, we have a formula V equal to U plus At, final velocity, V for final velocity, U for initial velocity, A for acceleration, T for time. So if we apply this formula here, V equal to U plus At, we got Vy equal to 0, but Vy equal to Uy plus Ayt, because Vy means vertical component of final velocity in y direction. So initial velocity in y direction plus acceleration in y direction plus time equal to 0. So Uy plus Ayt equal to 0. So Uy, vertical component of velocity, initial velocity how much? U sin theta. What is Ay? What is acceleration acting on the body? It is acceleration due to gravity Z. But body is going up, which we have taken positive direction. Acceleration acting down will be negative. So G value will be negative. So in the place of acceleration, we can take minus Z. Because acceleration is acting downwards. So that's why we are taking minus Z here. In the place of T, we can take time of ascent, because for going maximum height, the time taken by it is called time of ascent, equals to 0. Or this GTA will come this side. We can write it as U sin theta equal to, this GTA will come this side, equal to GTA, G into time of ascent. If G comes downside, U sin theta by G means TA, time of ascent equal to U sin theta by G. So in this way, children, we can find the equation for time of ascent for a oblique projectile. But we have to remember one thing here. So while going for reaching the maximum height, the time taken by it is called time of ascent. From the maximum height, for reaching the ground, the time taken by it is called time of descent, which is equal to time of ascent. Time of descent also is equal to time of ascent, means which is equal to U sin theta by Z. So time of descent also equal to U sin theta by Z. We can have one more equation for time of descent. Not only that, so while going up, time of ascent, while going down time of descent. Means during time of ascent and during time of descent, during both the times the body is in the air. Means the time spent by the body in the air, which is known as time of flight, capital T. Time of flight, which is equal to sum of time of ascent, sum of time of descent. Time of ascent is u sin theta by z. Time of descent also u sin theta by z. If we add both u sin theta plus u sin theta, time of flight equals to 2u sin theta by z. 2u sin theta by z. So, okay, children, now we have got equations for time of ascent, time of descent, time of flight. Time of flight is a combination of time of ascent and time of descent. Next, children. Next, maximum height. How to find maximum height? So, in the case of projectile, this is maximum height point. From the ground, this distance how much? From the ground, what is the length of this maximum height? H max or HM. What is the value of HM that we have to find? So, as the projectile ascends means moving up. As the projectile ascends, the vertical component of velocity decreases continuously, and at maximum height, the vertical component of velocity will become 0. Means when the vertical component of velocity will become 0, means the projectile cannot move vertically at that place. It can move only horizontally at that place. Means at the highest position, projectile moves horizontally only, not vertically, where at its highest position, because vertical velocity is becoming 0. So here, children, so we have from equations of motion, because oblique projectile means it's an example of what motion, children? It is under the influence of z, means throughout its journey it is affected by acceleration due to gravity, which is uniform. So this motion is an example of what? Uniformly accelerated motion. Uniformly accelerated motion. So for uniformly accelerated bodies, we can apply equations of motion. So we have v square minus u square equal to 2as. This equation of motion is there. With the help of this, in the place of v square, we can keep 0, because at maximum height, v value is 0. In the place of u, we can take u sin theta, vertical component of velocity, vertical component of initial velocity. So u sin theta whole square 2as, because body is going up while throwing. While throwing, body is going up. Upward direction is taken as positive. Acceleration acting downwards. So g is taken as negative. So in the place of acceleration, we can keep minus g. In the place of distance, we can keep hm, because the distance traveled is equal to hm, maximum height, hm. Okay. So next, so 0 square equals to 0. So we have minus u square sin theta whole square, u square sin square theta equal to minus 2gh. minus 2gh. Or this minus cancel. This 2g will go here, go down. U square sin square theta by 2g equal to hm. So in this way, we got equation for this maximum height. The equation for maximum height in the case of oblique projectile is hm equal to u square sin square theta by 2z. U square sin square theta by 2z. So children, we have got the equation for maximum height. Before that, time of ascent, which is equal to time of descent, and time of flight is 2 times of time of ascent, 2u sin theta by z. So altogether, 4 formulas we have got. Time of ascent 1, time of descent 2, time of flight 3, and maximum height 4. So for the oblique projectile, 4 equations we have got. So here, in this children, this height will be maximum, we are telling, but this value will be maximum if theta value is what? The body will go to maximum height. The body will go to maximum height. If you throw with 30 degrees angle, it will go to one height. 45 degrees, one height. 50 degrees, another height. Like that, if you throw with what angle, its maximum height will be maximum ever. Means, in trigonometry, the sin theta will be maximum at sin 90 degrees. Because sin 90 degrees value is 1, means when theta equal to 90 degrees, so this hm, maximum height, h max will be u square by 2g, because sin theta value will become 1. This will be u square by 2g, and oblique projectile, if we throw with 90 degrees velocity, it will be equal to a body projected vertically upwards. So in this case, it can reach maximum height. So when theta is 90, h max will be still maximum. Next, another equation we have to find, which is horizontal range. So horizontal range means, suppose if this is the projectile, from the point O, we have thrown the projectile, it has reached A, maximum height. From there, again it came back to B, to the ground. So here, horizontal distance traveled by the projectile while it touches the point on the same level of point of projection is called horizontal range. Means, from what level we have thrown the body, if it has reached to the same level, so from the same level, this horizontal distance, this OB length is called horizontal range. So in horizontal range, while we are considering the horizontal range, we have to consider horizontal component of velocity. Suppose if we have thrown with u, the horizontal component of velocity is u cos theta, which is always constant. U cos theta is always constant. Constant velocity means there is no acceleration. Means normal formulas we can apply in the case of horizontal motion. So horizontal velocity remains constant in the case of oblique projectile. So normal formula means we know that velocity equal to displacement by time. So here displacement is OB, which is equal to horizontal range. Velocity is u cos theta, horizontal component. Time is equal to the time taken for reaching from O to B is nothing but equal to time of flight. Equal to time of flight. So we have velocity equal to displacement by time. In the place of velocity, we can take horizontal component u cos theta. In the place of distance, we can take range r. In the place of t, we can take time of flight, capital T. So now r equal to, this t will go up, tu cos theta. R equal to u cos theta into t. U cos theta into t. But this t value, 2u sin theta. 2u sin theta. Because double than time of ascent. So in the place of capital T, we can keep tu sin theta by z. Tu sin theta by z. So u into u square. So u into u square. Here cos theta, 2 sin theta. We can write it as 2 sin theta into cos theta by z. But 2 sin theta into cos theta in trigonometry, it is equal to sin 2 theta. So u square, this we can replace by sin 2 theta by z. This is the formula of horizontal range. Horizontal range. So fifth equation also we have learnt. Okay, children. So what we have learnt, children? We have learnt about time of ascent we have learnt, which is equal to time of descent. Time of ascent, time of descent, if both we add means it will be equal to time of flight. That equations we have learnt. And we have learnt to derive the equation of maximum height, which is equal to u square sin square theta by 2z. It is maximum when theta value is 90. When theta value is 90, the oblique projectile will become vertically projected upwards body. And for horizontal range also, we have derived the formula, which is equal to u square sin 2 theta by z. Okay, children. The remaining part we can learn in our next video. So, children, thank you for watching our video. So, please subscribe our channel and press the bell icon for receiving latest updates. You can visit our website, children, www.aimstoday.in for previous classes. For other classes like coding, English, reasoning, all the classes, you can visit our website. Thank you, children. Have a good day.